Before long, we endeavor to create a perfect world, but inadvertently, we forgot the pure essence of light. Green and environment-friendly consumption of light energy has always been the dream of the global community. Green world, green environment, green photovoltaic energy. To fulfill this dream, we commit ourselves to the monocrystalline solar power systems. And from here, our journey starts. Since 1839, human being has started to explore the photovoltaic PV technology. The first monocrystalline photovoltaic cell was produced in 1954, and the first commercial photovoltaic power plant was built in 1982. Though built 30 years ago, many monocrystalline PV power plants in Switzerland, China, the United States, and Japan keep running. In provinces of Gansu, Yunnan, Zhejiang, and Xizang of mainland China, a lot of PV power plants, which equipped with monocrystalline modules, have been continuously running for 20 to 30 years. In 2013, HIT monosolar cells, which have a conversion rate of 25.6%, broke the record of the highest efficiency in the solar cell industry. Monocrystalline modules employ monocrystalline silicon of semiconductor-grade quality, which have nearly perfect crystal structure, and the metal impurities and dislocation defects only about 1,000th as those in normal crystalline silicon chips. Pureness results in high efficiency. Having no grain boundaries, monocrystalline materials have excellent mechanical properties, which are less prone to cracking during manufacturing, transportation, installation, and operation, and they also have lower long-term attenuation. Measured data from Qinghai, Ningxia, Zhejiang, Guangdong, and other places have shown that monocrystalline power plants generate 5% more electricity than other crystalline power plants of the same capabilities, indicating a clear efficiency advantage of monocrystalline modules that could bring significant savings investment. Compared with other crystalline systems, a monocrystalline system can save 200 acres of land, 8% of infrastructure costs, 320 tons of steel, 80 kilometers of DC cables, and 5% of labor costs. Furthermore, a monocrystalline system could meet higher environmental requirements, for it has anesthetic values. Let's explore more about the process how monocrystalline PV modules are manufactured. First, high-purity polysilicon materials are fed in a monocrystalline furnace, where cylindrical monocrystalline silicon rods form with a dragging of seed crystals under a strict control of the semiconductor wafer growth process to limit the crystal defects. In a second step, the monocrystalline silicon rods are processed to cut off heads, tails, and side surfaces to become standard-sized silicon cuboids, which are then cut quickly and accurately with diamond wires to turn into perfect monocrystalline silicon wafers. In a third step, textures are introduced on surfaces of monocrystalline silicon wafers to form light-trapping pyramid structures in order to improve the ability to capture light, followed by disposing anti-reflection coatings, printed electrodes, and the electric field on the surfaces of the silicon wafers to become high-efficiency monocrystalline cells after sintering. In a fourth step, the monocrystalline cells are connected in series and assembled with the EVA, glass, aluminum frames, and junction boxes to ultimately turn into electricity-generating units. Both the selection of raw materials and the process for manufacturing ensure the advantageous characteristics such as high efficiency and high reliability of monocrystalline modules, which in turn has translated into remarkably reduced costs in investment and in power generation, and has therefore borne the hopes in our pursuit of a perfect world and the promises in our retrieval of the originally pure rays of light.